Hello students, here is our second video of the P2. So from the previous we can see write an equation to show how butane can be produced by the byproduct of this reaction. So we can say C2H5 free radical plus C2H5 free radical, and these two free radicals forms C4H10. So this is the termination step and for the production of butane, or as I mentioned earlier, it is the formation of only the hydrocarbons. It may be the only alkane. So the next question 3 is ethane reacts with, so I am changing the color. So use the bond ethane reacts with a chlorine to form chloroethane. Use bond energies from the data booklet to calculate the enthalpy change for this reaction. Include the sign in your answer. So this is quite easy. If we draw the total bonds, we can see this is ethane and this is the chlorine. So here we can see only the product side. Here we can see only one carbon hydrogen bond is being broken and one Cl-Cl bond is being broken, and there is only formation of CCl, one CCl bond, rest all are the same CH, and these are not affected. So one HCl is being formed. So we can see on the reactant side, as we know bond breakage is endothermic reaction. Bond breakage is endothermic. We can say the bond energy of one CH bond, that is almost 410, and Cl-Cl bond energy is 242. So this is the plus, this with the plus sign because the bond is being broken. So total it is 652, and after that we can say the CCl bond is being formed. So the bond energy of CCl bond is 340, and after that, and we are saying the CCl bond is being formed. So the bond enthalpy for the CCl bond is 340, and for the bond formation of HCl it is a 431. So collectively it becomes 771. So overall, describing the reaction while it is exothermic or endothermic, we can say 652 minus 771, it is equal to minus 119. So this is the sign that is negative. It is showing the reaction is overall exothermic reaction. So the next is state the condition needed for this reaction to occur. There are condition, actually this is free radical substitution, and in this step we are using the UV rays, or we can say the sunlight. This is being used. Use a series of equations to describe mechanism for this reaction and how butane can be produced. This is as such as the previous, in my previous video I described the whole steps. This is the repeating. And chloroethane can be converted to back into ethane by the two-stage process via intermediate compound X. So here we can see this is monohaloalkane, and with the help of reaction 1 it is being converted into X. So what changes are going into X, and it forms the ethane. As we know, when we are going to dehydrohalogenation of monohaloalkane, and this will form the alkene. If we remove HX from monohaloalkane in the presence of alcoholic KOH, so it form the alkene C2H4. And if we use the hydrogen, and we can say this reaction is hydrogenation of alkene, and in this reaction nickel or PT, PD are catalyst being used, and alkane will be formed. Give the name of the X. The name of the X will be alkene, or we can say simply ethene. Suggest the reagent and condition needed for reaction 1. So as I mentioned earlier, alcoholic KOH or alcoholic NaOH, and heat reflux will be given. And what is the reagent and the conditions? So reagent is KOH and the conditions are alcoholic KOH. So suggest the reagent and condition for reaction 2. A reagent is hydrogen and the conditions actually which are PT, PD and all these things which are being used as catalyst. So the question number 4, heptane, an undesirable component of petrol as it burns explosively causing the knocking in the engine. There are 9 structural isomers with the formula, only 2 of which contain the chiral centers. Explain the meanings of the term structural isomer and chiral. So structural isomer, we can say the structural isomers are those structures, the isomers which have the same molecular formula but different structural formula. So here we can see the chiral carbon, actually we can say the atoms or the center or the carbon in which 4 different components are being attached. So this is called as chiral. Give the structure and the names of 2 structural isomers which contain the chiral carbons. So here we can see these are the 2 structures which I am going to draw here. One is the 3-methyl hexane